In this video, we will analyze a series circuit with 3 resistances. There are 3 resistors of 100, 200, and 300 ohms respectively. They are connected to a source of 20 volts, positive and negative. The first thing we do is find the equivalent circuit, known as the Thevenin equivalent. The 3 resistances are in a series. The formula for this will be the sum of the values in the series. If it is a parallel circuit, we must use a different formula. But this is a series circuit, and because one resistor is followed by the others, we can use this formula. We only have one supply source, 20 volts. Here, we have an equivalent circuit with only one resistance. The value of this equivalent resistance will be the sum of these 3 resistances. So we add 100 plus 200 plus 300. Our total resistance will have a value of 600 ohms. In this equivalent circuit, there will be an equivalent current. The network that we just calculated is 600 ohms. Now, applying Ohm's law to this equivalent circuit, we use the formula V equals I multiplied by R. I know there's only one supply source or voltage of 20 volts. The current I will be the total, and the total resistance, or R in this case, is 600 volts. Total current I is 20 volts divided by 600 ohms. The total I is 0,0333. The unit of this current will be amperes. We can also say the total I is 33,3 milliamperes. We can leave it in amperes, or we can convert it to milliamperes. Now, what is the total current, or I? The total current I comes from the source. So, 33,3 milliamperes total current passes through resistances R1, R2, and R3, and it returns to the negative pole of the source. With the pure series circuit, pure, not mixed, as there is no other path for the current to take, it passes through resistors R1, R2, and R3. The total current I is equal to that of the total current that crosses resistance R1, and equal to the current that crosses resistance R2, and equal to the current that crosses resistance R3. The formula for total current I is I1 equals I2 equals I3. This formula only works in series circuits. Both of these formulas only work in series circuits. With series resistance, we apply this formula, and we have to keep this in mind. Okay, so I know that total currents I1, I2, and I3 are equal, and in this case, they would be equal to 0,0333 amperes, or 33,3 milliamperes, which are equivalent. With the table, they can also ask, what is the voltage of resistance R1? We know the value of the resistance of R1. It's 100 ohms. We know that the current I that passes through it is 0,0333 amperes. So to calculate the voltage V1, I will apply Ohm's law. V1 equals I multiplied by R1. So I know that I1 is 0,0333 amperes, and we will multiply it by the value of R1, which is 100. And we get 3,33 volts. So I have calculated the value of voltage V1. It's the same for voltages V2 and for V3. So finding voltage V2 would be equivalent to current I2 multiplied by resistance R2. Substituting I2, which is equal to I1 and I3, I will write 0,0333 multiplied by 200, which is the value of R2. And we get 6,66 volts. Voltage V3 is the same. We take current I3 multiplied by resistance R3. If we want to, we can write it in milliamperes instead. So we write 33,3 multiplied by 10 to the negative third power. This is the same as 0,0333 amperes. We will multiply it by R3, which is 300, and we get 9,99 volts, which is nearly 10 volts. I'm going to calculate all of the remaining values of voltage and power. Now, the 20 volts that I have here, if I did it correctly, these original 20 volts of the source in a series circuit will be distributed to the different elements that are connected with each other. 20 volts has to be equal to the sum of V1 plus V2 plus V3. This is what we are going to check. So V1 is 3,33 plus V2, 6,66 plus V3, 9,99. In total, this should be equal to 20 volts. And this only happens in series circuits, not in the other kinds of circuits. What do I have to do to calculate the power? Power, P1, is equal to voltage, V1, multiplied by current, I1. It's the same for power P2 and power P3. You can calculate these values. Which unit will I end up with? Here, I always multiply the volts by amperes, so I will end up with watts. Watch out, because if I use milliamperes here, then over here I have to use milliwatts. My advice is to always use volts and amperes, so you end up with watts.